Name ZENER diode characteristics. Here we are doing two parts. First part to plot volt ampere characteristics of ZENER diode. Second one to find breakdown voltage in reverse bias condition. Next to verify ZENER diode has voltage regulator. These three we are doing in this experiment. Required components are ZENER diode 1N4735A. Resistor 1 kilo ohm, breadboard, regulator power supply, digital multimeter. Instead of digital multimeter, we are using voltmeters and ammeter here. This is voltmeter and ammeter. 0 to 2 volts and 0 to 100 milliamp. This is the connections of the ZENER diodes. These connections are same as PN diode forward bias connections. Same procedure, everything same as PN diode forward bias. No need to verify again. Say PN diode forward connection. So because I am not showing any connections to you. PN diode, ZENER diode, anode and cathode. Black color coated material called a cathode. If you observe carefully, black color coated materials is called cathode. This terminal anode. This is the forward bias. ZENER diode forward bias characteristics. By varying voltage, observe the VA characteristics of the ZENER diode. It is same as PN junction diode. So I am not showing anything clearly. I am given 1.4 volts applied voltage from the RPS. Voltmeter reading 0.758, meter reading 0.6. Okay, this is the ZENER diode, PN ZENER diode characteristics. This is the forward bias, ZENER forward bias readings by varying applied voltage. Observe current applied voltage from the RPS we changing 0.1 to 2 volts. We have observed voltage and current. Experiment ZENER diode reverse bias. In reverse bias, connections are polarities of the ammeter and voltmeter changed and diode is reversed. Observe here, diode is reversed. This is the connections of the ZENER reverse bias characteristics. Voltmeter range 0 to 2 volts, ammeter range 0 to 100 milliamp. Previous in PN junction diode we are using microamp because it does not conduct current in reverse bias. So we are using microamps of this ammeter. But here it's conduct current, so we are using milliamp of the meter. By varying the applied voltage, observe the output readings. I am giving slowly points reading. If you observe, again 2.9 not changing. Whenever I am giving voltage, high voltage changing, current is slowly increases. Even I have given 10 volts, it's showing voltage reading 5.21. It is called a ZENER constant voltage. For ZENER diode, we have different ZENER diodes, constant voltage diode. In our laboratory, we are using 5 volts constant ZENER diode. So here voltage is constant at the 5 volts. If we are using 12 volts, voltage is constant at the 12 volts. It is a breakdown point. Whenever voltage is constant, at that point current is conducting, at that point is called, even I given 19.8 volts, voltage is constant. We have to observe this point clearly in ZENER reverse bias. It is very important point. This is called a ZENER breakdown voltage. What is the ZENER breakdown voltage? Minus 5.29 volts. ZENER diode reverse bias readings. Observe here applied voltage 1 to directly give 1, 2, 3 to 18 and V voltage, parallel voltage. Whenever breakdown we reach the breakdown voltage, then current increasing slowly. This is the ZENER breakdown voltage minus 5. For everything we get minus 5. This is the ZENER diode voltmeter.